The last equation we use is number 4. It's VF squared equals VI squared plus 2AD. We'll use this equation when we have VF, VI, A, and D, and when we don't have time and we don't need time. Solving for VF, you have one extra step because VF is by itself to start. However, it has a squared. So if you're solving just for VF, you'll put your numbers in, but you have to still get rid of the squared. The opposite of squaring something is to take the square root. So if you take the square root of both sides, you'll cancel the square on this side, and you'll have VF equals, and you'll get your number, and then you'll have to take the square root of that whole number. So VI squared plus 2AD. So you'll calculate all of this, and when you're done with that calculation, you'll take the square root of that answer, and it'll give you VF. Solving for VI is similar, except VI doesn't start by itself. So the first thing to do to get VI by itself is to subtract everything else that's being added. So the opposite of adding is subtracting, so I'll subtract this whole thing, 2AD, and I'll do that from both sides, 2AD. If I have VI squared and I add 2AD and take it away, it cancels out on there, and I'll have VF squared minus 2AD equals VI squared. Now, VI is isolated, it's by itself. However, the squared is still there. So I'll do the same thing I did before. I'll do the opposite of that. Take the square root of something squared, gets rid of the squared. And at this point, I'm left with VI equals the square root of VF squared minus 2AD. So when you calculate it, you'll put in your number for VF and square it. You'll subtract 2AD, and when you have that whole number, you'll take the square root of that answer. Solving for A would look something like this. You want to get the A by itself. You can't divide until you don't have anything added or subtracted anymore. So the first thing I'm going to do is subtract VI squared from both sides. In doing that, I get rid of it here, and on this side I have VF squared minus VI squared equals 2AD. Now, if I'm solving for A, I'm going to divide by everything else. So 2D, divide by 2D, cancels that out, and the rearrangement that I get here, I end with A equals everything here. VF squared minus VI squared over 2D. Solving for D is similar. I have VF squared equals VI squared plus 2AD. I need to bring the VI squared over there. Currently it's being added to this. The opposite is subtracting, so I'll do that on both sides. And I have VF squared minus VI squared equals 2AD. And the last one I was solving for A, so I divided by 2D. This time I'm solving for D, so I divide by 2A. Cancel both of those out, and this time I've got D by itself, so my final one is D equals VF squared minus VI squared divided by 2A.